everyone, welcome to today's One Cool Thing. In this video, we're going to talk about some latest models for fake news detection. Firstly, let's talk about how news fakes. The universe of fake news is much larger than simply false news stories. Claire Wardle of the First Drop News has created this helpful image to help us think about the ecosystem of mis and disinformation. Misinformation is false or inaccurate information that is mistakenly or inadvertently created or spread. The intent is not to deceive. Disinformation is false information that is deliberately created and spread in order to influence public opinion or obscure truths. Those 7 types of fake news in the form of the text are common in our lives and thus are necessary to be detected. Nowadays, due to the quick development of social media, fake news can now be in any form, such as articles, images, or videos. For lack of fact-checking or third-party filtering, an individual can broadcast fake news easily and at a large scale. Typically, they will publish on the sites that specialize in bogus or sensationalized stories, tending to use provocative headlines for propagation. Commonly, those pairs of headlines and images can be classified into those 5 types listed on the slide.
I will introduce 2 datasets which are frequently used to train the fake news detection model. The first one is Liar. It contains about 12,000 human-labeled short statements, and these statements are mostly sampled from TV interviews and campaign speeches. This dataset also offers a well-balanced distribution of labels, which can be divided into 6 categories: pants fire, false, barely true, half true, mostly true, and true. And here is an example of a statement made by Donald Trump on his presidential announcement speech, which is labeled as pants on fire. And the second dataset is called Faked It, which is a multimodal dataset sourced from Reddit. It not only contains the text itself, but also collects information like a relevant image, its author, and comments. In short, this dataset provides a more comprehensive and nuanced understanding of the context, and it has the potential to improve the performance of fake news detection in the real-world scenario.
A novel hybrid approach has been raised this May. It has used fine-tuned BERT as word embedding and light GBM for the classifier. It first excluded certain patterns and data for pre-processing. Then they feed the data into BERT to produce language representations combining position embedding with token embedding. Position embedding is based on MLM, which can randomly mask the input tokens so as to retrieve the original token of the masked word. Also, next sentence prediction and word piece embeddings are utilized to generate a better embedding rather than context-free model. To fine-tune the BERT, a fully connected layer with a softmax classifier is added. This step generates the contextualized embeddings for the input data by extracting the last hidden state of the BERT. The embeddings are fed into light GBM for classification. This sum of decision trees chooses to split the tree leafwise, as it often has smaller nodes at the same depth. It used Gauss to pick the instance with a large gradient. It can minimize the amount of data while maintaining the accuracy. Using EFB, it bundles sparse high-dimensional, mutually exclusive features to a single feature. As a result, the training process may significantly speed up when the dataset is huge without compromising the performance.
Now I will talk about the importance of fake news detection. Fake news detection is crucial to both humans and NLP models. For humans, fake news detection can preserve information integrity, meaning that the information we consume is accurate, reliable, and trustworthy. If we do not take actions, the misinformation can spread rapidly through various digital channels. Fake news detection technology helps identify, flag, and combat fake news and misinformation, and ultimately letting humans to make informed and trustworthy decisions. For NLP models, fake news detection technology is also very important. We know that NLP models learn from existing resources, including training data. Fake news, on the other hand, can pollute the training environment for NLP models. In this case, these models may generate false information, which causes serious ethical problems. So, Implementing fake news detection can significantly reduce the influence of fake news on NLP models, ensuring they learn from more accurate and trustworthy sources.